What are partial fractions? Okay, so partial fractions is a way of splitting a rational function into two fractions with linear denominators that are still equal to the original function. So if we have, let's say, 1 over x squared plus 5x plus 6, we want to split this into two equations. And let's just say we have that over something here plus b or something, right? So just something, right? And it has to be a linear denominator. Tends to be, it doesn't have to be. So something important is that partial fractions cannot be split up if it's improper. So that means that the power on the bottom has to be greater than the power on the top, because if not, then we cannot work. So this is a numerator. The power of the numerator has to be greater than the power of the denominator. As we can see here, 3 is greater than 2. Therefore, we need polynomial division in order for this to split up and actually have a proper fraction, because the remainder will give us that. Now, what tends to be really useful when we do this is for integration, but we won't go into it further. But in order to actually do partial fractions, once we've had a proper fraction or improper, we first of all have to factorize. Factorize denominator. And so this is pretty straightforward depending on the question. So let's just have 1 over x squared plus 5x plus 6. So we know that this quadratic can turn into x plus 3, x plus 2, right? Okay. Now what we're going to do is that we place those two linear fractions as a denominator separately. So now we have x plus 3, x plus 2 equals, or the same as, a, because we don't know the numerator, x plus 3, which we have from here, and then plus b over x plus 2, which we got the denominator from. So always when we get the linear denominators, we move them to the other side and we show them like this. Now, in order to figure out what a and b is, to actually have the two proper fractions, we multiply everything to one side. So we multiply x plus 3, x plus 2 to everything. So if we multiply everything by x plus 3 times x plus 2, we have 1 equals, or the same as, let's just have just equals for now, a, and we know that we're going to times everything by x plus 3, x plus 2. So we have this, plus, I don't have enough space, x plus 3, x plus 2, right? And then we have x plus 2 here. Now, we do know that this will cancel out, as well as x plus 2, because, multiplication, we know that this can be simplified. And now we have a x plus 2 plus b x plus 3. Now, what we want to do here is, remember, we're trying to figure out what a and b are, not what x is. So what can we do to figure out b and then figure out a? Because that's what we need to do. Well, we know that if we do x equals minus 2, a will cancel out, because minus 2 plus 2 is 0, and a times 0 is nothing, plus b, but we know that x is minus 2. However, this does not cancel out. We have minus b at the end. Sorry, we just have plus b, because minus 2 plus 3 is 1. And that has to all equal to, remember, to the left side, 1. So if a canceled out, that means that just 1 equals b. We've already figured out b. Now we need to figure out a. So what can we do to cancel out b and find a? Well, we know that if we put there minus 3, we'll cancel out b, and we still won't cancel out a. So we do 1 equals a minus 3 plus 2 plus b minus 3 plus 3. And we know that therefore it's b times 0, cancels out, and then we have minus a, because minus 3 plus 2 is minus 1. Minus 1 times a is minus a. And we all equal that to the left side, which just leaves us with this. 1 equals minus a. Now, all we have to do simply is substitute those two values back in to the equation. So if we know the equation was like this, plus 6 is the same as a over x plus 3 plus b x plus 2. And we know the values now. All we have to do is just input them. Minus 1 over x plus 3 plus 1 x plus 2. And that is literally the answer. So that's basically the easiest way to do partial fractions. The only problem I will tell you is maybe sometimes you won't just simply have, let me just show you, you won't just have a 1 up here, but rather you could have 4x plus 2 over x squared plus 5x plus 6. But we know that this won't actually affect anything, maybe just when we're doing the substitution, because if we split it again, and we know that it's going to be x plus 3 plus b x plus 2, and we multiply all the sides, because we know this can be like linear, we'll just have 4x plus 2 equals a x plus 2 plus b x plus 3. And so the only difference is that when we substitute x equals minus 2 or x equals minus 3 to cancel a or b, we just have to substitute 4 times minus 2 plus 2 equals to the a side, we just have minus 8 plus 2. So basically, because we know this is going to cancel out because a is going to be times 0 plus b. So we know that the difference is that once we're substituting that here, instead of when we had 1, when we're trying to figure out here 1, and we try to cancel out these values, here we don't have just 1, because we're substituting the minus 2 or 3 in here. And so now we have 4 times minus 2, minus 8 plus 2, 6 equals b. So that's really the only difference I'll tell you in those simple linear partial fractions. Now, there's two other ways I will tell you that you should be aware of. And that's when sometimes there cannot always be linear denominators, because sometimes a power to 2 or 3 cannot be simplified. Let's say, for instance, x squared plus 4. This cannot be simplified any further. This cannot be factorized any further, if that makes more sense. You know, why? Because it is, you just can't. Because we know that if we try to find the roots of this, it will be complex numbers. And we know this because if we do x squared, x squared plus 4 equals 0. When we have this, we know that we're going to get a square root minus 4. And that's instantly complex numbers. Sorry for my writing. Okay, so what we have to do in this situation, if we have, let's say, assuming we've already factorized fully, if we have x plus 3, x squared minus 4, we just do the same thing as we've done before. X plus 3 plus b x squared minus 4. Now, the only difference I will say is that once we're obviously multiplying everything to the other sides, etc., and we get a x squared minus 4 plus b x plus 3, there's only a simple catch to this, right? It's not just gonna be like that, because once we multiply, we want to also have bx plus c, and I will show you this when we write. So what we have to do, in fact, is that we don't just put b, because we know that once we're multiplying when we're multiplying by this factor, right, because it's not fully linear, right, we have to do with the fraction that has that, we need to put bx plus c. So another example would be if we have x squared minus 5, let's just say, and that's the way you can only factorize it. Then if we have a plus something plus b x squared minus 5. That just cannot just be b. It has to always have bx plus c, because we know that we will have more values, because this is not just going to be x plus 3 or something. It's a quadratic, so therefore multiple values in this instance. So once we have bx plus c, that means that once we have everything multiplied out, we're going to have plus bx plus c on that side too. So we have to figure out a way to cancel out a or c in order to find the values, yes? And so the easiest way usually to get certain values is by, let's start with canceling out a, because let's say if we do a is 0, then we're gonna have, it's gonna be 2, then we have a 2 minus 4, so a 0 cancels out, plus we input 2 into the b area, 2b plus c, and now we have x plus 3, and we put 2 plus 3, which is 5. Now we just have 5, 2b plus c. Remember, we have the left side equals 1. 10b plus 5c equals 1. So obviously we still have missing values, but that is not to worry about, because if we simply just do minus 2 now, because we know that technically 2 values can cancel out here, 2 and minus 2 because it's squared, we can now do a minus 2 squared plus 4, minus 4, which we know will still cancel out because minus 2 times 2 is 4. So a 0 cancels out. But the other side, we'll have minus 2b plus c times minus 2 plus 3, which is just 1. So therefore, we have, this is still equal to 1. So therefore, we have 1 equals minus 2b plus c. And that, now that we have these two values without a, it is a simultaneous equation. So now we can just do 1 equals 10b plus 5c, and then 1 equals minus 2b plus c. And as we know, this is pretty straightforward because we can literally substitute the 1. We can substitute this into here, and then boom, we figured it out, etc. So that's how it would work. However, this is not always the case. I will tell you that. It's not always the case. This is probably one of the most complicated ones sometimes. But usually what you'd get in these scenarios is that here, you can probably cancel out 2 values. So let's say if we had here, let's say we had here, we substituted here minus 3. It would cancel out all of this, and we figure out a, because a doesn't get canceled out. And then we could figure out values here differently that could cancel out c without canceling out a, etc. So in reality, all these rules is just knowing how to substitute values that will help you cancel out, which is the point of what we've been doing here all the time. Lastly, the only thing I will tell you, this one trick, is that we know that sometimes we can have, let's say, x plus 2 divided by x plus 1, x plus 2 squared, because we have a repeated root. In order to show this in the partial fractions, we do a x plus 1 like we've done before, and then plus b x plus 2, and then plus c x plus 2 squared. If this was to be cubed, then we plus d over x plus 2 cubed. That's how it works. It's basically n, and then we add the amount of n's we do here. That's how it works. Because let's say we had 4 would have x plus 2, x plus 2 squared, x plus 2 cubed, etc. Do you understand what I'm trying to say? That is how we do it. And once we get to that point where we're multiplying, it's the same thing again. You know, if once you understand that rule and you equal everything, you have x plus 2 plus bx plus 3 plus bx plus c, because remember we're going to have a squared or something, times something. You just do a bunch of substitution like we've done before to cancel out here, to cancel out here. That's the general rule. Lastly, we do need to understand, if they give you a question like this, plus 3, plus 2, sorry, let's remove that, plus 1. And then when you use partial fractions, but they tell you the domain means x cannot equal minus 3, or x cannot equal minus 2. This means we cannot use substitution because these values will be useful to input in order to cancel and figure out a and b. And so what we do instead is that we compare coefficients. When we compare coefficients, it is when we do a, when we do a x plus 3 plus b x plus 2, let's say for the question above, when we multiply that by the original, sorry, I don't have space, but you understand what I'm trying to do here, you will have a x plus 2 plus b x plus 3 equals 1. We just have to do expand. Because when we expand this, we're going to have bx plus 3b. And now we just compare coefficients. We know that 2a plus 3b, because they're coefficients, not coefficients, just integers, plus ax plus bx equals 1. That means that 1 equals 2a plus 3b, and 0 equals ax plus bx. And this is the simultaneous equation we will have. Because it's actually not x, it's just a plus b. That is the simultaneous we have, and then we solve it and we get a and b. That is basically all we have to know for partial fractions.